Hi students, in this video we are going to begin the Newton's law of motion. We are going to first cover the first law, which is known as law of inertia. The first law states that if an object is at rest, then it will remain at rest, or if it is moving along a straight line with uniform speed, it will continue to keep moving unless an external force is applied on it to change its existing state. In this example, you see that the net force acting on the object is 0. So there is no velocity, it remains at rest. In the second one, again the net force acting on the object is 0. So it has a velocity, so keep going on with this velocity. The first law of motion is also known as law of inertia. Inertia means the tendency of an object to resist its change of motion. That means it remains at rest if it is at rest, or it continues its motion if it is in motion. When you're driving a car, when the brakes are applied, you feel a force forward. Because when you're driving a car, you are going with the same velocity of the car. But when the car tries to stop when the brakes are applied, you want to keep your motion forward, so you feel a force of inertia that will keep you or conserve your motion going forward. Again, think of that you're in a stopping car, but then suddenly it starts to move, then you remain stationary, seeming thrown backwards. You're on a stopping car, and the car or the bus tries to go forward, but you would like to keep your previous motion, so you feel a force of inertia in the backward direction. So that's why we have to use our seat belts. The seat belts save our lives. When driving your car, your velocity is the velocity of the car. When the car stops suddenly or crashes, then the seat belt will prevent the force of inertia. But if you are not using a seat belt as seen here, then this force of inertia will push you forward and it may damage you. Now let's summarize the direction of the inertial force. If the car is accelerating in the rightward direction, you will feel a force of inertia in the opposite leftward direction. If the car is decelerating, the deceleration is in the negative direction of the motion, then you will feel a force of inertia in the opposite rightward direction. So in acceleration, you will feel a force in the opposite direction of motion. If you are in a car decelerating, then you will feel a force of inertia in the same direction of motion. Let's do an example. Compare the tensions on the ropes if the wagon is accelerating in the given direction. We're going to compare T1 and T2 and T3 to T4. Now, as the car is accelerating in the rightward direction, then the force of inertia will be in the leftward direction. So T2 will equalize the tension T1 plus the force of inertia. So the tension in the second rope will be bigger than the tension in the one. And in vertical direction, we have the weight of the object. So T3 will equalize the tension for and the weight. So T3 will be bigger than T4. In this example, we have three elevators. They are moving upwards. The first one is moving with constant velocity, so the acceleration of the elevator is 0. So there is no inertial force here. So the tension in the spring will be just equal the weight of the object. The second one is accelerating up. As it is accelerating up, there will be a force of inertia in the opposite direction. We have again the weight of the object, so the spring will be under the influence of these two forces. The third one is decelerating up. In deceleration, the force of inertia is in the direction of motion. We have the weight of the object here, so the spring will be under the force of the weight minus the force of inertia. So when we compare the lengths of the springs, you see that there's more force on the second spring, so its length or extension will be bigger than the first one, and there's the least force on the third spring, so its extension will be the least.